Engineers, problem solvers. We've been talking about motion, and we know that motion is movement. We know that there's motion types. One example is back and forth, like the drum, or spinning, like a hand mixer, up and down, like an elevator, or jumping, and zigzag, like that snake was moving. Now today we're going to look at page 162 in your science book, so make sure you're following along, page 162. And the heading is called Moving Many Ways. Moving many ways. Follow along as I read. An elevator only moves up and down, but often an object moves in more than one way. When you walk somewhere in school, you may go upstairs, so up and down, or walk back and forth along the hall, zigzag around people in front of you, and circle around the room to get to your seat. Watch this video to discover more about patterns of motion. The machines that package this medicine repeat the same motions over and over. So I want you to see what types of motions there are. Okay, so just tell me what you see here. This is a factory that creates medicine. Notice what's happening already. What motion is that? Yeah, it's spinning, right? Oh, and now it's going down. Okay, so that had multiple motion. What is this one doing? Yeah, do you see how it's going here and then here? What is that? Well, that could be a zigzag or it could be a back and forth. I would even take up and down because it's kind of moving down. Lots of different motions there. What about this one here? What's happening here? What motion do you see? Yeah, I see spinning. The bottles are spinning. Remember, this is a factory, so machines actually do this with the bottles. It looks like it's medicine, and they're going to put the medicine in the bottles. What motion is this? Right, it's zigzagging. What about this one? What motion do you see? All right, let's look at the page 163. It has some fill in the blank for you. It says, think about another example of motion, moving luggage or your bags through a busy airport. Moving through a crowded airport is similar to moving in a crowded hallway at school. Choose the best words or phrases to complete the sentences. Here we go. When luggage, your bags, are taken out of a plane and lifted onto a cart, it has a blank pattern of motion. What type of motion is it if you're lifting your bag out of the plane? Choose the correct answer. Sorry, you should have chosen up and down. Okay, if you haven't written that, you should. The next question says, the bag's motion pattern is on the moving luggage carousel. Think about a carousel. It's like a merry-go-round. What type of motion does it have? If it's a carousel or like a merry-go-round, what type of motion is that? Right, it's circular, it's spinning. To avoid banging into other people in the crowded airport, the owner walks with the bag in a blank motion pattern. You're trying to avoid running into people, so what are you going to do? You're going to zigzag around them. You want to back away so you don't run right into them. While leaving the airport on level ground, the bag's movement follows a blank motion pattern. Back and forth. Okay, so you should have these 4 answers for number 5. If you need to pause and fix any of your answers, do that, and then move on to the next thing here. I'll read this real quick. When the bag was lowered from the plane and lifted onto the cart, it followed an up and down motion pattern. The bag's motion pattern was circular on the moving luggage carousel. To avoid banging into other people in the crowded airport, the owner walked with the bag in a zigzag motion pattern. While leaving the airport on level ground, the bag's movement followed a back and forth motion pattern. Now this is like an extra credit thing. So this is something that you can do at home and you can send me for maybe an extra Starbucks or 2. It's called engineering motion. It's a think about materials you could use to make a path for a marble to roll along. How could you cause the marble to move in different ways? Design a path to make a marble move in several different patterns. Make a detailed drawing of your design below. Be sure to label the materials in your drawing. If your teacher provides the materials to do so, build and test your design. So if you do this on your own, maybe after you finish your work or maybe at home, I can give you marbles and you can actually make your design, but you would have to have it labeled and drawn. Okay? Look at the bottom of page 163. It says, when you roll a ball downhill, what do you expect it to do? When you roll a ball up a hill, what do you expect it to do? So this is kind of a matching thing, and yours is a fill in the blank. So I just want you to answer this question. If you roll a ball down a hill, what's going to happen? But if you roll a ball up a hill, what's going to happen? So pause this and answer number 7, and then you can turn the page for the next part. Page 164. How will it move? When you see a pattern of motion, you can predict how an object will move next. You can predict that the hands of a clock continue to move in a circle, but you cannot predict a butterfly's next movement. Okay? So we have a few things here, and you need to tell me what type of motion you think it will be. We're kind of making a prediction here. The first one is a Ferris wheel. Is that going to be zigzag, circular, downward, or back and forth? Think about a Ferris wheel. I want you to write your answer. You should have circular motion because it's a Ferris wheel. It goes in a circle. What about a window washer on a platform at the top of a tall building? Imagine someone washing a window. What type of motion is that going to be? Well, it's going to be downward because they're starting at the top of the building and working their way down. What about an adult rocking a baby in a rocking chair? They're rocking. What's the answer there? What type of motion is that? Yeah, they're rocking back and forth, back and forth. What about a snow skier moving down a hill, making a wavy path? Yeah, that's going to be zigzag. So this is another opportunity for you to pause the video and check your work. Okay, it's time for some more predictions. We're going to watch these videos and make some predictions. What type of motion do you think will happen next? I'll take the captions off. Okay, so you see the train moving. The toy train's motion is easy to predict because it will go where the track is. You can see exactly where it will go next. So see how it's going into the tunnel? Well, what's next? It'll come right back out. So I know where the train's going to go because it can only stay on the track. This is a very predictable motion. I can predict what's happening next. What about a swimmer? Can I predict what's going to happen next? She jumped up, which means she'll go right back down. It's very predictable. I can tell what's going to happen next. Divers bounce to go up, and then they fall right into the pool. What about all those fish, the turtles, the scuba diver? Can I predict what they're going to do next? I can predict that the turtle's going to keep flapping his arms, but I don't know where he's going to go. It's very unpredictable. What about these animals? I see a predator and I see some prey. Who's the predator in this? Yeah, that cheetah. Now, I can make a prediction that he's going to get one of those animals, but I don't know where they're going to go. They're moving in a very unpredictable way. I don't know where they're going next. All right, so now we're going to take these pictures, and I'm just going to show you that this one is predictable, and these ones are not, just like we talked about. So now I want you to look at number 9. This is on page 165. It says, predict each next motion to tell whether or not it's a pattern. So you're just going to tell me a piece of toast is lowered into the toaster. Is that a pattern or no pattern? Well, I think it's a pattern because if I put the toast down, what's it going to do? It's going to pop up. Okay, I want you to do the same with these ones. Oh, and this one is an up and down motion. Oops. Okay, so for these three, I want you to pause the video and answer these. The wheels on the bus move the bus. Is that a pattern or no pattern? What type of motion is it? You're playing soccer. Pattern or no pattern? What type of motion is it? So I'll just put pattern here. Okay, pattern, and I'll let you do the rest. Dribble basketball. Pattern or no pattern? What type of motion is it? Pause the video to answer those questions. The last one on page 165 is think of some predictable motion in games and sports. Write an example of a way that predicting motion can help you win a game. So pretend you're playing a game of soccer or a game of basketball. Why would it be important to make a prediction of what the other player is going to do next? How would that help you win a game? Pause the video and answer that question, please. I'll even give you a sentence starter. Predicting helps me win a game because. Okay, there's your sentence starter. Okay, you can finish that sentence and then continue on. So pause the video and answer that question. All right, page 166. Engineering art in motion. Engineering can be used to create devices that do useful tasks. It's also used to make wonderful pieces of moving art. Theo Jansen is an artist who uses engineering to build strand beasts. His newest versions have taken many years to make. He builds each new sculpture using what he learned from the ones he built before. Engineers use the same method of trial and error and improvement. So this strand beast can move in many different ways. Some parts move in a zigzag. Some parts move in a circular motion. Others move back and forth and up and down. So watch it in motion. So cool. Look at all the different motions. This took him a very long time to make, but he made this. Look at all the different motions, circular, back and forth, zigzag, up and down. Super cool. Theo Jansen calls his creations animals. He has even given them Latin names, the way real animals are named, and refers to a group of them as a herd. Here's your question. How do the motions of strand beasts remind you of the ways animals move? So if you need to go back and rewatch that, do that and tell me, how does it remind you of an animal? Write your answer here. What reminds you of an animal on that? Pause the video and answer that question. All right, the last page, page 165, motion inside of motion. Earth is in motion all the time. It moves around the sun. It also rotates. It spins around one complete turn every 24 hours, which is one day. You can't watch Earth rotate, but you can observe one effect of it turning. You see day and night every 24 hours because where you live on Earth turns toward and away from the sun. So when it's toward the sun, it's daytime. When it's away, it's nighttime. You can also see that Earth rotates if you watch a Foucault pendulum. Watch this video of the Foucault pendulum inside a museum. A pendulum slowly changes the direction of its swing, matching the turning of Earth. In 24 hours, the pendulum swing makes a complete circle. Here's a time-lapse video. Remember, that speeds it up. It makes it look like it's spinning faster than it really is. Here we go. I'm going to get rid of this. Notice how it's swinging a lot faster than it actually is. They sped this up. All right, your job now is to answer 12 and 13 on the bottom of your page. So you have a fill in the blank. Every few seconds, the Foucault pendulum swings back and forth. However, over the course of the day, it actually moves in a circle. So pause this video to check your work And then I want you to answer 13 on your own.